In this video, we are going to see how to use TypeORM in a Node.js and Express application. To get started, go ahead and clone this starter project from GitHub. The link is below the like button. Let's open this project in VS Code. Now, execute the command npm install to install all the required packages. I recommend using Node.js version 22. Next, install TypeORM and other necessary packages. In this case, I'm installing mysql to package because I'll be using mysql for the database. You'll need to install the package for your specific database. You can view a list of all supported databases on your screen. Now, import reflect metadata at the top of the main file. Remember, this should be the first line of the main file. Now we need to modify the tsconfig file to enable two flags. Open tsconfig file and uncomment experimental decorators and emit decorator metadata. Let's create a datasource file inside the db folder in our src directory. The datasource file holds our database connection settings and establishes the initial database connection. In this datasource, the type property is set to mysql since we are using mysql for the database. This will change depending on your database type. We have also configured other connection-related properties such as host, port, username, password, and database name. You may need to adjust these values based on your database configuration. We have a property called synchronize. This will be set to true when the node_env is not set to production. When synchronize is set to true, TypeORM will automatically create, update, or delete tables and columns in the database to match our entities whenever the application starts. An entity is a class that serves as a blueprint for a table in our database. We can define columns, their data types, and other properties within this class to define our table's structure. As you can see, we have an entities array. We can either define each entity individually or provide a path to the folder containing all our entities. In our case, we've specified the path to our entities folder. Another property we have is migrations. In this migrations array, we specify the list of migration files that TypeORM should use to update your database schema. Migrations are files that contain code to make incremental changes to the database, such as creating or modifying tables and columns. This is the recommended approach for making changes in a production environment. That's enough information about datasource. Now, let's establish connection with the database. To establish a connection with the database, we need to initialize the datasource. We'll do this in the main function of the main file so that our database connection is established as soon as our application starts. Now, let's create an entity called post. We'll start by creating a class called post and then adding the @entity decorator above it to make this class an entity. In the post entity, we have an ID column. To make this column automatically generate ID, we've added the @primary generated column decorator above it. This column could be a UUID, an auto-increment numeric sequence, or something else depending on your database and configuration. For this example, we use UUID. Next, we have title and content columns. These are simple columns, so we've added just the @column decorator above them. With this decorator, we can configure various aspects of the column, such as its type, name, and so on. Next, we have a status column that is an enum. This column can only have two possible values, published and draft. Finally, we have created and updated columns. For the created column, we've added the @createDate column decorator. This decorator automatically manages timestamps for when a record is created. For the updated column, we've added the @updateDate column decorator. This decorator automatically updates the value of the column to the current timestamp. We've completed the entity setup. Now, let's write some code in our post service file to create a new post. First, we need to retrieve the repository by calling the getRepository method on the datasource we created earlier. This provides us with various methods, such as find, save, delete, and more. To create a new record, we can invoke the save method and provide the necessary data. This will create a new record in our post table within the database. Now let's try to call this function. The starter code already includes the required code to call this function, allowing us to directly make an API call to the post route to create a new post. Let's make the API call. In the API call, we'll send the title, content, and status as parameters in the request body. We encountered an error message indicating that something went wrong. The reason for this is that by default, a column length is set to 255, but our content exceeds this limit. To resolve this issue, we'll modify the content column type to text. Congratulations! Our post has been successfully created, and we can now view the record in the database. Now, let's proceed to writing code for retrieving all posts. To obtain a list of all posts, we can simply call the find method. Similar to creating a post, we have all the necessary code already set up to execute this function. Therefore, let's make an API call to retrieve the list of all posts. Excellent! We now have a list of all posts in the response. That concludes the video. Please subscribe to our channel and hit the bell icon to support our growth. Additionally, consider liking the video for your appreciation.